In this video, we're going to explain the line of best fit. So let's say you have two parameters. You have the weight and the speed of the person. So the weight determines the speed of the person, so we call the weight the independent variable, and the speed is the dependent variable. So let's say we have a table like that. Generally speaking, as someone becomes has more weight, his speed will decrease generally, but this is not always the case. So let's say if someone has a weight of 60, maybe his speed is 20. And maybe if someone has a weight of 70, then his speed is 18. And then maybe 80 have a speed of 19, and then 90 becomes 16, and a weight of 100, someone has a speed of, let's say, 14. So if you sketch this on an XY plane, you'll put the independent variable, the weight, and the speed depends on the weight. If you plug in this value, let's say someone who has a weight of 60 has a speed of 20. So it's this point here. If someone has a weight of 70, his speed is 18, and 80 is 19. So you see that there's a small fluctuation. Maybe someone has more weight but more muscle, so he can run faster, and 90 and 16 and 114. So the line of the best fit is the line that goes through most of the points, or actually in the middle of the points. So generally it will look something like this. It passes through most of the points, or at least the closest distance between all of the points. So the line, this is what we call the line of best fit, and this serves as an estimate for the data. So this line is, I can say that it's an estimate for the data. And why do we consider it an estimate? Because it actually does not represent the real life. So the real life says that if someone has a weight of 18, from the data collected, he should have a speed of 19, which is this point. So this point, we call it the actual point, because this is the one we actually measured, right? But the line, we write it as an estimate. And the benefit of this line is it represents a continuous range. So let's say in the table you don't have someone who weighs 82 kilograms. So how do you know his speed? Well, simply you go here to 82 and you go up. You will not find an actual point, but if you project here, it will hit the line of best fit, which we said is going to give you an estimate. So if you read this from here, then you know the speed of the person at weight of 82. And using the same logic, you can find an estimate for the speed of any person throughout this range, from actually 60 kilograms to 100 kilograms. But at 80, if you extend your line here at 80, you'll find a different estimate for the speed than the actual point. And this is what we call usually the error, which is the difference between the estimate and the actual points. So again, the steps goes as follows. We sketch the actual point, we plug in the line of best fit, and this serves as an estimate for all the range. And the difference between the estimate, which is, in other words, we can call it the value predicted by the line of best fit, and the actual value at the 5 points that we got is what we call the error, or simply the difference between the actual value and the estimate value at a certain point.